Hello students, welcome to Creata Classes. I am Gurmeet Singh and also welcome to complete series on chapter Circle for class 10 students. We will cover all these lectures in this series using the power of visualization and animation. In this lecture, especially in this lecture, we will cover exercise 10.2 question number 6 to question number 10. The link to other lectures is given in the description. Check it out. So without taking any further time, let's start with this lecture. Let's start with question number 6. The length of a tangent from a point A at a distance 5 cm from the center of the circle is 4 cm. Find the radius of the circle. So this is the question. The wording of the question is slightly tricky. So firstly, let's understand the wording. In the question it is given length of the tangent from a point A. So we have a circle and we also having a point A from which a tangent is starting. Point A at distance 5 cm from the center. This point A is at the 5 cm distance from the center. So this distance will be 5 cm. Of a circle is 4 cm. Here this 4 cm is the length of the tangent. The length of the tangent is 4 cm. Okay, so this is the tangent and the length of the tangent is given as 4 cm. This is the radius and we have to find the radius of this circle. So this is the question. Let's start. Here firstly we will apply the theorem 10.1, that is the radius and tangent are perpendicular to each other. This means this angle will be equal to 90 degree. On observing, we got a right angle triangle in the given figure. This is a right angle triangle. Once we got a right angle triangle, we can easily apply the Pythagoras theorem, that is the property of a right angle triangle. The hypotenuse is 5 cm. How we know that? Hypotenuse is the side which is opposite to 90 degree angle. So the hypotenuse is 5 cm and we have to calculate the radius. Let's use the Pythagoras theorem. Let's put the value. On solving, we got radius square is equal to 9. So the radius is 3 cm. That is the answer of the question. Got it? So let's move to question number 7. Two concentric circles are of radius 5 cm and 3 cm. Find the length of the chord of the larger circle which touches the smaller circle. This question is somewhat resembling the NCERT example number 1. Let's approach this question. This question is talking about two concentric circles. Concentric circles are the circles which are having the same center point. So these are the two circles, concentric circles. Let's give the name to the circle as C1 and C2. The radius of bigger circle is given as 5 cm and the radius of smaller circle is given as 3 cm. Further in the question, a chord to the bigger circle is given which is touching to the smaller circle. And we have to find the length of this chord. Let's give the name to this chord as AB and we have to calculate the length of this chord. This concept is very interesting. Here this chord AB belongs to the circle C2, the outer circle, and also this chord is acting as tangent for the smaller circle C1. Got it? What is tangent? Tangent is a line segment which touches the circle at only one point. So AB is touching the circle at only the point P. So AB is tangent to the circle C1. And what is chord? Chord is a line segment which touches the 2 points on the circle. So AB is the chord for the circle C2. So this is a basic concept based on which we will solve this question. The radius of the bigger circle is given as 5 cm. It means OA and OB will be equal to 5 cm. And radius of smaller circle is given as 3 cm. It means OP is 3 cm. Further, AB is tangent to the circle C1. And if we apply the theorem 10.1, that is the radius and the tangent are perpendicular to each other. So we got OP is perpendicular to AB and these angles will be equal to 90 degree. Got it? On observing, are you able to figure out the two right angle triangle? This is a right angle triangle and this is also a right angled triangle. And in the question we have to find the length of AB, the length of the chord. So we can apply the Pythagoras in both the triangles separately and we can find AP and PB, the two distance, and we can add to get the complete length AB. Let's do so. Let's apply the Pythagoras in the triangle OAP. OA square is equal to OP square plus PP square. OA is 5 and OP is 3. Let's put the value. We got AP as 4 centimeter. One segment of the chord we got AP as 4 centimeter. Let's apply the Pythagoras in the triangle OPB. OB square is equal to OP square plus PB square. OB is 5 and OP is 3. Again we got PB is equal to 4 centimeter. So AP and PB both are equal to 4 centimeter. So we got the complete length of chord AB as AP plus PB, which is 4 plus 4, total 8 centimeter. That is the answer of the question. The length of the chord is 8 centimeter. This is very interesting concept. You should note it down. Whenever we are having two concentric circles and the chord of the outer circle, the bigger circle, is touching at one point of the inner or the smaller circle, then the chord of the bigger circle will act as a tangent for the smaller circle. So this is one of the important concepts. You should know it. We have done with the question number 7. Let's move to question number 8. A quadrilateral ABCD is drawn to circumscribe a circle. Prove that AB plus CD is equal to AD plus BC. Here in the given figure, we are having a circle and also a quadrilateral ABCD. And quadrilateral ABCD is circumscribed around this circle. And this quadrilateral is touching the circle at point P, Q, R and S. And we have to prove that AB plus CD, that is addition of these two line segments or the side of the quadrilateral, is equal to AD plus BC, these two sides of the quadrilateral. So let's approach the question. Here we will use the theorem 10.2. As per theorem 10.2, the length of the tangent drawn from the external points are equal. Here if you observe, we are having various tangents to this circle. If we take the point A, here AS and AP are the tangent. If we take the point B, here BP and BQ will be the tangent. Similarly, from the point C, these are the two tangents, and from the point D, these are the two tangents. And we know from an external point, if we draw the two tangents toward the circle, both tangents will be equal to each other. The theorem 10.2. The same concept is also applicable here. So let's use the same concept. Firstly, let's take the point A. From the point A, we are having the two tangent AP and AS. So we got AP is equal to AS based on theorem 10.2. Similarly, from the point B, BP and BQ are the two tangents. We got BP is equal to BQ. Similarly, CR will be equal to CQ and DR will be equal to DS. The theorem 10.2 we have applied. We got 4 equations. Let's add all the 4 equations, left hand side on the left hand side, right hand side on the right hand side. We got AB plus BP plus CR plus DR is equal to AS plus BQ plus CQ plus DS. Here AP plus BP, can we write these two terms AP plus BP as the complete length AB? Similarly, CR plus DR will be equal to the complete length CD. AS plus DS is equal to AD and BQ plus CQ is equal to BC. Just we have added the two line segment to form the complete line segment or the side of the quadrilateral. So we got AB plus CD is equal to AD plus BC. That is the answer. That is the proof of this question. Got it? We have used the theorem number 10.2, that is from an external point, the tangent to the circle are equal to each other. Let's move to question number 9. Students, information for you. Download the PDF of the formula and concept list for this chapter. The link is given in the description. There you will also find the similar PDF of the concept and formula list for other chapters too, especially for the class 10 student. So check the link in the description, and now back to the lecture. In figure 10.13, xy and x-y' are two parallel tangents to a circle with center O and another tangent AB with point of contact C intersecting xy at A and x', y' at B. Prove that angle AOB is equal to 90 degree. Slightly a complex type of question, not complex, slightly a lengthy question. Firstly, let's observe this question. In this question, we are having a circle with center as O, and we are also having two tangents, xy and x dash y dash, and these two tangents are parallel to each other. Okay, here OP and OQ are the radius, and if we apply the theorem 10.1, the radius and tangents will be perpendicular to each other. It means angle P and angle Q will be equal to 90 degree, the theorem 10.1, just one of the observation. Let's move further and further observe this figure. Here in the question we are also given a third tangent, the tangent AB. So this is the tangent AB and it is touching the circle at point C. And also the point A is touching on the first tangent XY and point B is touching on the second tangent X dash Y dash. And we have to prove that this angle, the angle AOB is equal to 90 degree. So this is a question. Let's approach this question. Firstly, let's join O and C, the line segment OC we got. If you observe, here we are getting 4 triangles in the given figure. So based on these 4 triangles, we will solve this question. The approach is that firstly we will prove both of these triangles as congruent to each other. Then we will prove both of these triangles as congruent to each other. And after that we will find these 4 angles. And based on these 4 angles, we will solve this question. So this is the systematical approach that we will use. Firstly, let's see these 2 triangles. Can we say these 2 triangles are congruent to each other? Let's see. Here OP and OC both are the radius of the circle, so both will be equal to each other. Further, OA in both the triangles are common, so we got OA is equal to OA, that is a common side. And AP and AC are the 2 tangents from the common point A. So from the point A we are having 2 tangents to the circle. It means these 2 tangents will be equal to each other. We have simply applied the theorem 10.2. Tangents from an external point are equal to each other. So these are the 2 tangents, also the 2 sides of the triangle. So these 2 sides or these 2 tangents are equal. We got AP equal to AC. All the 3 sides of both the triangles are equal. So by side congruence rule, we can say both the triangles are congruent to each other. Got it? Similarly, we will prove these 2 triangles also as congruent to each other. Here OC and OQ are the radius, so both are equal. OB is common in both the triangles. And BC and QB are again the 2 tangents from an external point B to the circle. So BQ and BC will be equal to each other. The same theorem 10.2 we have used. B is the external point and BC and BQ are the 2 tangent to the circle. So both are equal to each other. So again for these 2 triangles, all the 3 corresponding sides are equal. So by SSS congruence rule, side congruence rule, both the triangles are congruent to each other. So in the first step, we got both of these triangles as congruent. In the second step, we got both of these triangles as congruent to each other. Once the 2 triangles are congruent, by CPCT, we can say the corresponding angles will also be equal to each other. CPCT, corresponding part of congruent triangles are equal. So these 2 angles are the corresponding angle. So these 2 angles will be equal to each other. Similarly, these 2 angles are the corresponding angle, so these 2 angles will also be equal to each other via CPCT. Let's move further. In the question, it is given that xy and x dash y dash are parallel to each other. And in the question number 4 of the same exercise, we have done that the tangent drawn at the end of the diameter of a circle are parallel. If these 2 tangents are parallel, it means PQ is a diameter. PQ is the diameter means PQ is a straight line. Got it? XY and x dash y dash are parallel to each other. It means PQ is the diameter. Remember that we have done the question number 4 in which we have proved these 2 angles are the alternate angle. Here this angle is 90, this angle is 90. So these 2 angles are the alternate angle. So through the concept of transversal, we have proved the same. PQ is the diameter we need because we need a straight line PQ. On a straight line, sum of all the angles is equal to 180 degree. Here PQ is a straight line. It means sum of all these four angles will be equal to 180 degree. Got it? Further, just now we have proved angle AOP is equal to angle AOC and angle BOQ is equal to angle BOC. Let's replace these two angles. On solving, we got angle AOC plus angle BOC is equal to 90 degree. And what is angle AOC plus angle BOC? That is angle AOB. The complete angle is angle AOB. So we got angle AOB is equal to 90 degree. That is the answer of the question. That is our proof. Are we able to correlate why we need PQ as the diameter? If PQ is not the diameter, then PO and OQ are only the two radius. And we cannot correlate it with the concept of a straight line, that is sum of all the four angles on a straight line will be equal to 180 degree. So our purpose will be defeated. So we need PQ as a diameter with a straight line. So we have done with the question number 9. Let's move to question number 10. Prove that the angle between the two tangents drawn from an external point to a circle is supplementary to the angle subtended by the line segment joining the point of contact at the center. Let's observe the question. Firstly, let's take a circle with center as O. The question is talking about two tangents from an external point. Let's have an external point P and let's draw the two tangents PA and PB. So we got the two tangent and also join OA and OB. OA is the radius and OB is also the radius. Here the question is talking about two angles. The first angle is the angle between the two tangent, this angle. And the second angle is the angle between the two line segment formed by joining the center and the point of contact. Here O is the center and the point of contact are A and B. So this question is talking about the line segment OA and OB and the angle between OA and OB. So this is the angle. So this question is saying to prove these two angles are supplementary. That is, the addition of these two angles is equal to 180 degree. So we have to prove that angle APB plus angle AOB is equal to 180 degree. This is the question. We have converted the wording into the simple mathematical form. So let's approach the question. Now it is looking very simple. Angle A and angle B will be equal to 90 degree. Why? We have simply applied the theorem 10.1. The radius and tangent are perpendicular to each other. The angle between radius and tangent is 90 degree. So this angle is 90 and this angle is also 90. Further, are you able to observe a quadrilateral in the given figure? So OAPB is a quadrilateral. And we know the property of a quadrilateral, that is the sum property of a quadrilateral. The sum of all the four angles of a quadrilateral is equal to 360 degree. Two angle we know is equal to 90 degree. Let's put the value. On solving, we got angle APB plus angle AOB is equal to 180 degree. That is the answer of the question. So we have done with the question number 10. So students, we have done with this lecture. If you have enjoyed, like and subscribe to our YouTube channel and also share this video with your friends and the class 10 student. We also have a similar kind of video, all the chapters for class 10 student. Check the playlist section of our YouTube channel. And best of luck for the exam you are preparing for and have a great day. Bye for now.